Hello everyone, welcome to Mind for Physics. This video is about vectors, which is the most important thing that is covered in the beginning of your physics course. And I do think that this is going to be something that will make or break your physics experience. So let's do some physics. Lecture plan is as follows, so we're organized and we know what we're doing. Part 1, why bother about vectors, obviously. Part 2, vectors and scalars. Part 3, how are vectors and scalars related? So let's start with part 1, done. So why bother and why learn about vectors? The first reason is a practical reason because they come up in every single chapter. And I'll show you a typical textbook in physics. Other ones will be similar. The concept of vectors is introduced in the beginning, chapter 2 here, and they're going to be used in every single chapter. So it's a high yield concept. You learn it once, and then you're going to need it throughout your course. Here, you're in the chapter 2 or in the beginning, you're going to learn that this is different type of quantity that you're used to. You're used to dealing with numbers. You know how to add numbers, you know how to subtract numbers, you know how to multiply and divide them. Vectors are different than numbers. They're going to have different rules of addition, different rules of subtraction, and multiplication. You'll have to add and subtract vectors a lot, pretty much all the time. You may not need to multiply them very often, and there is no such thing as division when it comes to vectors. But these two operations, addition and subtraction, are very useful. So you're going to learn these basic rules of handling quantities like vectors, and they are going to be different than numbers. And then vectors, as you can see, are going to come in all the time because there are vectorial quantities in physics or in the real world, and therefore in physics. So the second reason why you should learn them is because they're actually useful, and you're going to see that in the coming slides. Here's a definition of a vector. I strongly recommend you learn definitions in physics. It's going to make this whole journey of physics easier for you. So what is a vector? Vector is a quantity that is fully described by magnitude and direction. So first and foremost, its type of a quantity. Vector is a quantity. It's type of quantity that has this feature or characteristic that it has to have both magnitude and direction. If you're a visual learner like myself, then this is a little image that summarizes this definition. So the popular examples of vectorial quantities in physics are velocity, force, displacement, also acceleration, and others that you're going to learn. So what does it mean that something is a type of a quantity that has magnitude and direction? If these things exist in the real world and I live in the real world, then I should be familiar with them. And in fact, we are. But maybe you don't know the name of this thing, but you are familiar with it, and you know this in your day-to-day life through your senses. So let's focus on one of these vectors, let's say force vector. And let's focus on magnitude separately and then direction separately. You know that the magnitude of a vector like force matters because if you were to press down your iPad screen with a small force, and small here pertains to the magnitude of 1 Newton, you know you're not going to break the screen. But if you press down the iPad with 100 newtons, you're going to break the screen. So you see that the magnitude, you just change the magnitude from 1 to 100, and 100 newtons is probably large enough that you would break your iPad screen. You know this, you don't do that. You don't press down fragile things with 100 Newton force. So your senses know that. So the magnitude aspect of a vectorial quantity such as force is going to generate different outcomes. So now let's concentrate on the direction part, not changing magnitude. If you were to rearrange furniture in your living room, you would push a table with a specific angle strategically to move it towards the place in the room that you want to move it to. So if you press down on the table, you're probably going to break it if you press hard enough. If you press table up from underneath, you're probably going to lift it up if you press hard enough. If you push table from a side, you're going to slide it. So you're going to generate very different movement depending on direction of the force that you apply. Part 2 of this little lecture is scalar quantities, because when vectors are introduced, another quantity is juxtaposed with it, and that's scalar quantity, because it's different than vector. And in a way, it kind of comes before vector. And scalar quantities are quantities that you have been dealing with your whole life, but when you get to your physics class, then you kind of get to name it. A scalar is a quantity that is fully described by magnitude or numerical value. So similar to vector, scalar is also a quantity, but different from a vector. It only has the numerical value, doesn't have direction. And there are quantities like that in the real world, such as mass. Mass is a quantity that is fully described by numerical value, in this case, 100. I don't need to tell you eastward, 100 pounds eastward. That doesn't even make any sense. The reason why there is no direction aspect to scalar quantities, such as mass, is because mass, if an object has mass of 100 pounds, it's going to have that same mass in every direction, eastward or westward, even in outer space. It's going to have the same mass. It's not going to have the same weight, because weight is a force. You'll learn that a little bit later. Also, same applies to volume. If something has volume of 6 ounces, it has that same volume in every which way you turn it. If I asked you what was the temperature in the room you're in, you're going to give me just a number. You're not going to say 75 degrees Fahrenheit eastward. That would be weird. You're not going to do that. So at this point, create 2 buckets in your head. Physicists have very organized minds. It looks like a container store in there. It's like a home edit. So you should create 2 buckets, one for scalar quantities and one for vector quantities. When you learn about quantity like mass or volume, you're going to toss that into a scalar bucket. And when you learn about velocity or force or acceleration, you're going to toss that into a vector bucket. And this is how you stay organized. So part 3 is, how are vectors and scalars related? If you're going to have these 2 buckets in which you're going to put all the new physical quantities you're going to learn, it's good to know the relationship between them. You may think that they're opposites of each other. So scalar and vector are in a similar relationship that hot and cold is, or black and white, or plus or minus is, like opposites, right? So that's not it, because if scalar is a quantity that is fully described by magnitude, then if vector was the opposite of that, direct opposite of that, it would have to be something like a quantity that is fully described by lack of magnitude. So it's a nonsense. It doesn't make any sense. So that's not the relationship. Another plausible relationship they may have is that scalar is part of a vector family, the way that humans are part of mammal family. So one is a smaller subgroup and one is a larger category. So that's not either, because in that case, mass, which is a scalar quantity, would also end up being a vector. And I hate that thought, because mass is never a vector. Mass is a scalar quantity. So the way that I like to think about them is, from scalar to vector, you're going from less information to more information. Scalar only gives you magnitude. Vector gives you magnitude and direction. So it actually goes in this order: scalar, vector, matrix, tensor. You learn about scalars in your school, then probably in high school or in college you learn about vector quantities, and the product of 2 vectors is going to be a matrix, and interaction of vector spaces is going to be a tensor. Don't worry about it. You're probably never going to get to tensor unless you want to become a physicist. And there's going to be different rules that you use to add scalars that you learn in school, addition of numbers. And that's not going to be the same as adding vectors. So there's going to be new rules that will allow you to add vectors. They're quite simple, so don't get scared. So thank you so much for sticking with me this far. I'm proud of you, and I am going to be here to help you succeed in physics. Thank you. Bye.